Okay, welcome back. Now we still in section 6.1 talking about the area, and this is question number 3 that we want to solve. It says that use calculus, which means we need to use the integration to find the area of the triangle with those vertices. So I have 3 points, they will form a triangle, and I need to find the area of the triangle. This question is a little bit different than the previous 2 questions because here I don't have the functions or the curves that will make for me the region. So the first step we need to do, as usual, we need to sketch this triangle with those vertices. And after that, we need to find the equation y equals something or x equals something in terms of y. So the first step we'll do is we just go ahead and sketch the triangle. Let me have a big sketch here. Maybe we can have a very big one here. Again, this is just a sketch. So you have the triangle. The first point is 2, 0. It should be somewhere here. And then I have 0, 2. Let's say here. And then I have -1 and 1. So I believe it should be, let's assume it is here. Now I need to join those 3 vertices, and I will do it with different colors. So this one will be blue, and then this one will be pink. And the last one, let's choose a different color. Let's do greenish. Okay, so now let's go back and try to find how do we find the equation of a line given that we have 2 points. I will just go to the second different page. Just let me add a new page here after this one. Okay. So the question now is we need to find an equation of a line passing through the points. Of course, the blue line was between the points 2, 0, and the other point is 0, 2. Now, just to remind you how we find the equation of any line, it's usually given by this equation, y minus y1 equal the slope m, x minus x1. So assuming this is x1, this is y1, this will be x2, y2. Okay, all what we need to do is, this is the equation of the line. Now, all what we need to do is we need to plug in y1, we need to plug in x1, and we need to find m. And how do we find m if we have 2 points? That's given by this equation. Let me just stick it here. M equal y2 minus y1 divided by x2 minus x1. So in my example, let's go back and see how much y2 was 2, x2 was 0, and the other point is the opposite. So y2 is 0 and then y1 is 2. If we evaluate this one, the answer will be -1. So that's the m. That's what we need to plug in here. So my equation of the line in the blue one will be y minus y1 is already 0 equal -1 for the slope, x minus x1, which is just 2. So if we simplify it, this is y equal -x. Of course, we can just distribute the -1 inside, plus 2. And that is the equation of the first line that we need. quick recall of what we did. We need to find the equation between 2 points, and it's a line. So the usual formula is given by y minus y1 equal mx minus x1. y1 and x1 already given, for example, from the first point, but then we need to find the slope m, and the slope m is given by this equation. You just plug in the numbers, you get -1, and then you get this equation. Let me go back and rewrite this equation up there. So here is minus x plus 2. Now this is the first function. We need to do the same thing for the green, and we need also to do the same thing for the pink. Let's go back and find it for the green. I'll just do it very quickly here. Let me just do it here. Now for the green, we have the same equation. We have 2 points, which is, it was 2, 0. And the second point was -1, 1. So this is y minus y1 equal mx minus x1. Okay, so it will be y minus 2 equal mx minus, sorry, this is 0. This is 2. Now the m is y2, which is 1, minus y1, which is 0, and then x2, which is -1, minus 2. So the final answer would be y equal, if we just find this one, it will be, I believe it's -1 over 3, x minus 2. If we distribute it, it will be -1 over 3x plus 2 over 3. And that's the equation for the green function. Now, let me do it for the last time, the equation for the pink function. Okay. And the line between the pink function was between those 2 points, 0, 2, and -1 and 1. So again, we need to find the m, which is, if this is x1, this is y1, this should be x2, y2. So it will be y2 minus y1, x2 minus x1, and that is just 1 minus 2 divided by -1 over 0. And the answer is 1. So finally, we have y minus y1 equal mx minus x1. So it is y minus y1 is 2 equal 1 x minus 0. So this will be just y minus 2 on the left side, and this will be just simplified to x. So y alone is just x plus 2. Now we found the 3 functions, and now let's go back to my sketch here. So this equation is just x plus 2, and this equation up here is just -1 over 3x plus 2 over 3. And here is the picture. We find 3 functions, and then we have my region in the middle. Now look at my region. If you look at my region, it's almost divided into 2 parts. I will just color them here. This is the first part, and then it will change into a different part, which is this one. Why it has changed? Because in the first part here, we have the top function is the blue and the bottom function is the green. This is the half region here, which is this one. And in this region here is the difference. The top function is the red and the bottom function is the green. So it's kind of 2 regions, and I need to find the area of each one almost separately. So let's go back and find the area now. So the area actually, it's kind of two areas. Area 1 plus area 2. Now what is area 1? Area 2 is the brown color here, and area 1 is the yellow one. Okay. If we know how to find one, I think we can find the other one easily. So the area 1 is, as usual, if you want to find the area 1, you have to put your rectangle, and that's my rectangle. I will put it here as vertical because everything is in terms of x. And I need to find the area of this rectangle, dx. It should be the top function minus the bottom function. The top function is the blue one minus the bottom function is the green one. Okay, and then I need to do the integration from somewhere to somewhere. How do I find from where to where? Look at your rectangle. If you move it maximum to the right, you will end up at number 2. So the top one is 2 here. And if you take the rectangle and you move it to the left, you maximum end up 0. So it should be a 0 here. So it is from 0 to 2. Of course, we are not done yet because we need to do the same thing for the second one. So this should be plus another integration, another triangle, another top, another bottom. Now, what is the top of the new triangle up here? Is the red function, negative the green function as usual. So the green is 1 over 3x. And the top function is the red one, which is x plus 2. Now, how do I find from where to where I should do the integration? It should be fairly easy because take your rectangle, move it maximum to the left, you will end up at minus 1. If you move it maximum to the right, you end up with 0. So it should be from 0 to negative 1 to 0. You have very simple two integrals. If you just do them at home, practice that, and please send me in the comments in the Microsoft Teams the final answer for me to check if you did the calculation correctly. Thank you so much for watching. Let me go and recall what we did in this exercise in 30 seconds. The question was to find the area of the triangle with 3 vertices. The first step, I sketched the 3 vertices and I sketched the triangle. And then I need to find every side of the triangle. I need to find the equation y equals something, or sometimes it could be x equal into something. I found them using the equation of a line, and then I figured it out that my region is divided into 2 regions, 2 different tops. The first one is the top is the blue one, which is this line, and the second region has a top, which is this one, which is the red line. And then I just use the equation for the area to find the answer. Thank you so much for watching, and now I will go and solve question number 4.